electrical energy on vehicles. It stores chemicals, not electricity. Two different types of lead in an acid mixture react to produce an electrical pressure. This electrochemical reaction changes chemical energy to electrical energy. Battery functions. 1. Engine off. Battery energy is used to operate the lighting and accessory systems. 2. Engine starting. Battery energy is used to operate the starter motor and to provide current for the ignition system during cranking. 3. Engine running. Battery energy may be needed when the vehicle's electrical load requirements exceed the supply from the charging system. In addition, the battery also serves as a voltage stabilizer, or large filter, by absorbing abnormal, transient voltages in the vehicle's electrical system. Without this protection, certain electrical or electronic components could be damaged by these high voltages. Construction. 1. Case. Container which holds and protects all battery components and electrolyte, separates cells, and provides space at the bottom for sediment, active materials washed off plates. Translucent plastic cases allow checking electrolyte level without removing vent caps. 2. Cover, permanently sealed to the top of the case, provides outlets for terminal posts, vent holes for venting of gases and for battery maintenance, checking electrolyte, adding water. 3. Plates. Positive and negative plates have a grid framework of antimony and lead alloy. Active material is pasted to the grid, brown-colored lead dioxide, Pb02, on positive plates, gray-colored sponge lead, Pb, on negative plates. The number and size of the plates determine current capability. Batteries with large plates or many plates produce more current than batteries with small plates or few plates. 4. Separators. Thin, porous insulators, woven glass or plastic envelopes, are placed between positive and negative plates. They allow passage of electrolyte, yet prevent the plates from touching and shorting out. 5. Cells. An assembly of connected positive and negative plates with separators in between is called a cell or element. When immersed in electrolyte, a cell produces about 2.1 volts. Battery cells are connected in series, so the number of cells determines the battery voltage. A 12 volt battery has 6 cells. 6 cell connectors, heavy, cast alloy metal straps are welded to the negative terminal of one cell and the positive terminal of the adjoining cell until all 6 cells are connected in series. 7 cell partitions, part of the case, the partitions separate each cell. 8 terminal posts, positive and negative posts, terminals, on the case top have thick, heavy cables connected to them. These cables connect the battery to the vehicle's electrical system, positive, and to ground, negative. 9 vent caps. Types include individual filler plugs, strip type, or box type. They allow controlled release of hydrogen gas during charging, vehicle operation. Removed, they permit checking electrolyte and, if necessary, adding water. 10 Electrolyte, a mixture of sulfuric acid, H2SO4, and water, H2O. It reacts chemically with the active materials in the plates to create an electrical pressure, voltage. And, it conducts the electrical current produced by that pressure from plate to plate. A fully charged battery will have about 36% acid and 64% water. One charged, a fully charged battery contains a negative plate of sponge lead, Pb, a positive plate of lead dioxide, Pb02, and electrolyte of sulfuric acid, H2SO4, and water, H20. 2 Discharging. As the battery is discharging, the electrolyte becomes diluted and the plates become sulfated. The electrolyte divides into hydrogen, H2, and sulfate, S04. The hydrogen, H2, combines with oxygen, 0, from the positive plate to form more water, H20. The sulfate combines with the lead, Pb, in both plates to form lead sulfate, PbS04, 3. Discharged. In a fully discharged battery, both plates are covered with lead sulfate, PbSO4, and the electrolyte is diluted to mostly water, H2O. 4 Charging. During charging, the chemical action is reversed. Sulfate, S04, leaves the plates and combines with hydrogen, H2, to become sulfuric acid, H2SO4. Free oxygen, 02, combines with lead, Pb, on the positive plate to form lead dioxide, Pb02. Gassing occurs as the battery nears full charge, and hydrogen bubbles out at the negative plates, oxygen at the positive. Capacity ratings: the battery must be capable of cranking the engine and providing adequate reserve capacity. Its capacity is the amount of electrical energy the battery can deliver when fully charged. Capacity is determined by the size and number of plates, the number of cells, and the strength and volume of electrolyte. The most commonly used ratings are cold cranking amperes, cca, reserve capacity, Rc, amp hours, A, power, watts, cold cranking amperes, cca. The cca rating specifies, in amperes, the discharge load of fully charged battery at 0 degrees Fahrenheit, -17.8 degrees Celsius, can deliver for 30 seconds while maintaining a voltage of at least 1.2 volts per cell, 7.2 volts total for a 12-volt battery. Reserve capacity, Rc, the Rc rating specifies, in minutes, the length of time a fully charged battery at 80 degrees Fahrenheit, 26.7 C, can be discharged at 25 amps while maintaining a voltage of at least 1.75 volts per cell. Amp hours, A, the amp hour rating specifies, in amp hours, the current the battery can provide for 20 hours at 80 degrees Fahrenheit, 26.7 degrees Celsius, while maintaining a voltage of at least 1.75 volts per cell, 10.5 volts total for a 12-volt battery. For example, a battery that can deliver 4 amps for 20 hours is rated at 80 amp hours, 4x20 equals 80. Power, watts. The battery's available cranking power may also be measured in watts. The power rating, in watts, is determined by multiplying the current available by the battery voltage at 0 degrees Fahrenheit, -17.8 degrees Celsius. Factors affecting charging: 5 factors affect battery charging by increasing its internal resistance. 1. Temperature: as the temperature decreases, the electrolyte resists charging. A cold battery will take more time to charge, a warm battery, less time. Never attempt to charge a frozen battery. 2. State of charge: the condition of the battery's active materials will affect charging. A battery that is severely discharged will have hard sulfate crystals on its plates. The vehicle's charging system may charge at too high of a rate to remove such sulfates. 3. Plate area: small plates are charged faster than large plates. When sulfation covers most of the plate area, the charging system may not be able to restore the battery. 4. Impurities: dirt and other impurities in the electrolyte increase charging difficulty. 5. Gassing: hydrogen and oxygen bubbles form at the plates during charging. As these bubble out, they wash away active material, cause water loss, and increase charging difficulty. Diagnosis and testing: all batteries require routine maintenance to identify and correct problems. A visual inspection can identify such physical problems. A state of charge test checks the electrolyte strength. Electrical testing identifies overcharging or undercharging problems. These tests include a capacity, or heavy load test. Visual inspection: 1. Check for cracks in the battery case and for broken terminals. 2. Check for cracked or broken cables or connections. 3. Check for corrosion on terminals and dirt or acid on the case top. 4. Check for a loose battery hold down and loose cable connections. 5. Check the level of electrolyte. The level can be viewed through the translucent plastic case or by removing the vent caps and looking directly into each cell. The proper level is 1/2 above the separators. 6. Check for cloudy or discolored electrolyte caused by overcharging or vibration. This could cause high self-discharge. The problem should be corrected and the battery replaced. 7. Check the condition of plates and separators. Plates should alternate dark, plus, and light. If all are light, severe undercharging is indicated. 8. Check for battery drain or parasitic loads using an ammeter. Connect the ammeter in series between the battery negative terminal and ground cable connector. 9. Check for battery discharge across the top of the battery using a voltmeter. If the meter reading is more than 0.5 volt, clean the case top using a solution of baking soda and water. Safety precautions: wear gloves and safety glasses. Remove rings, watches, other jewelry. Never use spark-producing tools near a battery. Never lay tools on the battery. When removing cables, always remove the ground cable first. When connecting cables, always connect the ground cable last. Be careful not to get electrolyte in your eyes or on your skin, the car finish, or your clothing. If you have to mix battery electrolyte, pour the acid into the water, not the water into the acid. Always follow the recommended procedures for battery testing and charging and for jump-starting an engine. Never disconnect the battery with the ignition on. Never use an electric welder without the battery cables disconnected. Never reverse battery polarity. State of charge test. The state of charge test checks the battery's chemical condition. One method uses a hydrometer to measure the specific gravity of the electrolyte. 2. Another method uses a digital voltmeter to check the battery's open circuit voltage. Specific gravity. Specific gravity means exact weight. The hydrometer compares the exact weight of electrolyte with that of water. Strong electrolyte in a charged battery is heavier than weak electrolyte in a discharged battery. Test procedure. State of charge test. 1. Remove vent caps or covers from the battery cells. 2. Squeeze the hydrometer bulb and insert the pickup tube into the cell. 3. Slowly release the bulb to draw in only enough electrolyte to cause the flow to rise. Do not remove the tube from the cell. 4. Read the specific gravity indicated on the float. Be sure the float is drifting free, not in contact with the sides of top of the barrel. Bend down to read the hydrometer at eye level. 5. Read the temperature of the electrolyte. 6. Record your readings and repeat the procedure for the remaining cells. Test results. 1. A fully charged battery will have specific gravity readings around 1.265. 2. Specific gravity readings below 1.225 usually mean the battery is run down and must be charged. 3. Readings around 1.190 indicate that sulfation is about to begin. The battery must be charged. 4. Readings of 1.155 indicate severe discharge. Slow charging is required to restore active materials. 5. Readings of 1.120 or less indicate that the battery is completely discharged. It may require replacement, but slow charging may restore some batteries in this condition. 6. A difference of 50 points, 0.050, or more between one or more cells indicates a defective battery. It should be replaced. 7. When the specific gravity of all cells is above 1.225 and the variation between cells is less than 50 points, the battery can be tested under load. Open circuit voltage. An accurate digital voltmeter is used to check the battery's open circuit voltage. 1. If the battery has just been charged, turn on the headlamps for 1 minute to remove any surface charge. 2. Turn headlamps off and connect the voltmeter across the battery terminals. 3. Read the voltmeter. A fully charged battery will have an open circuit voltage of at least 12.6 volts. A dead battery will have an open circuit voltage of less than 12.0 volts. 4. A battery with an OCV of 12.4 volts or higher is charged enough for load testing. If the voltage is less than 12.4 volts, charge the battery first. Battery load test. While an open circuit voltage test determines the battery's state of charge, it does not measure the battery's ability to deliver adequate cranking power. Battery load test is used to measure terminal voltage while the battery is discharging at high rate. The load is applied using a tester that includes a voltmeter, an ammeter, and a carbon pile resistor. Manufacturer specifications gives the cold cranking ampere amps, cca, for the battery. This data is used to determine the load to be placed on the battery. Testing procedure. Some manufacturers recommend removing the surface charge by applying a 300 ampere load to the battery for 15 seconds. Wait for 15 seconds. Apply a load equal to 1/2 the cold cranking ampere. After 15 seconds, read the voltage and remove the load. Battery voltage should read 9.6 volts or higher. If voltage reading is below the minimum, recharge battery and retest it. If a battery fails, test the second time it is defective. Battery charging and replacement. Two methods of battery charging are slow charge and fast charge. In slow charge, the battery is given a charge of a few amperes for several hours. In fast charge, the battery is given a 30 amp charging rate for 30 minutes. For further charging, charging rate is reduced to 20 amp or less for 3 more hours. Note: during charging a battery, disconnect the ground cable from the battery to protect electrical and electronic components from high